Namaste. This video is continuation of my last video of math tricks on squares and square roots. By the end of this video, you will know some more interesting facts and patterns in squares and square roots of natural numbers. Let us consider a square of first few natural numbers 1, 2, 3, 4, 5 and 6. And their squares are 1, 4, 9, 16, 25 and 36 respectively. You know, all of them are perfect squares. Now count the natural numbers between these two successive perfect squares, say between 1 and 4. We have two natural numbers, 2 and 3. I can say that there are two non-square numbers between these two squares. Next, take 9 and 16 and count those non-square numbers between these two consecutive squares. This time you will find 6 such numbers, 10, 11, 12, 13, 14 and 15. Keep going and perform the same experiment with 25 and 36. This time you have 10 such non-squares between two consecutive perfect squares. Can you see some pattern? The number of non-squares between squares of 1 and 2 is 2. That is 2 multiplied by 1. The number of non-squares between squares of 3 and 4 is 6. That is 2 multiplied by 3. The number of non-squares between squares of 5 and 6 is 10. That is 2 multiplied by 5. And you will find the same pattern if you count the number of non-squares between 4 and 9 or between 16 and 25. Based on this observation, I can conclude that in between squares of any two consecutive natural numbers n and n plus 1, there exists 2n non-perfect squares. We shall use this conclusion in solving problems. Another interesting fact. This time add first few odd numbers. First odd number is 1 and we can also say this is equal to 1 square. Adding first two odd numbers, that is 1 and 3, we get 4. 4 is same as 2 square. Adding first three odd numbers 1, 3 and 5, we get 9 which is equal to 3 square. Taking first 4 odd numbers 1, 3, 5 and 7, we have the sum of 16 which is 4 square. And first 5 odd numbers 1, 3, 5, 7 and 9 add up to 25, that is 5 square. And the list will continue. You can see some obvious pattern here. The sum of first two odd numbers is 2 squares. The sum of first 3 odd numbers is 3 square. The sum of first 5 odd numbers is 5 square. So I can say that the sum of first n odd numbers will be equal to n square. Another way of saying the same thing, a perfect square has to be the sum of successive odd numbers starting from 1. Rephrasing this statement, if a natural number cannot be expressed as sum of successive odd numbers starting from 1, then it is not a perfect square. Now some questions. How many natural numbers lie between 99 square and 100 square and between 200 square and 201 square? In this question, if I go for calculating the squares and then count the numbers in between, then that will be sheer wastage of time. Instead, I will use the trick we learnt in this video. Between square of two consecutive natural numbers n and n plus 1, there will be 2n natural numbers which are not perfect square. Therefore, between 99 square and 100 square, I will have 2 into 99, that is 198 natural numbers. And between 200 square and 201 square, I will have 2 into 200, that is 400 natural numbers. Another question. Find whether following is a perfect square or not. We have 25 and 19. Just now we have seen that a natural number that cannot be expressed as sum of first few odd numbers starting from 1 is not a perfect square. I will use this trick here. For that, first I remove 1 from 25. I end up with 24. Then I remove the second odd number 3 from this difference. I have 21. Then subtract the next odd number 5 from this difference and I get 16. Remove next odd number 7 and I have 9. And if I subtract the next odd number 9 from this difference, which is itself 9, I have 0 as the difference. Getting 0 as the difference means that 25 is sum of 1, 3, 5, 7 and 9. That is first 5 odd numbers. And if 25 is the sum of first 5 odd numbers, then it is a perfect square. Now repeat the same exercise for 19. Subtracting 1, I have 18. Then subtracting 3, I get 15. 15 minus 5 is 10 and 10 minus 7 is 3. If I remove the next odd number 9 from 3, I get minus 6. Since I never get 0 and jump over to negative side, it means that 19 is not the sum of first few odd numbers and hence not a perfect square. The technique we have used in this question is although not very efficient and works only for small numbers, but still an interesting fact to know. One more interesting pattern is visible when you see the square of numbers that has all digits equal to 1. Square of 1 is equal to 1. 11 square is equal to 121. The square of 111 is 12321. 1111 square is 1234321. And if you square a 5-digit number with all digits being 1, you will have 123454321. That's quite interesting. And based on this pattern, you can straight away write square of a number that consists of only 1 as its digits. Let us take a question where we have to find the square of 1111111. This number consists of 7 digits with all of them being 1. So I can straight away write its square equal to 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1. Another interesting pattern. Look at the following squares. 7 square is equal to 49. Square of 67 is 4489. Square of 667 is 444889. Square of 6667 is 4444889. And square of 6667 6, 6, 7 is 4, 4, 4, 4, 4, 8, 8, 8, 8, 9. Following this pattern, I can write a square of 6, 6, 6, 6, 6, 6, 7. When the number had 2 6s and 1 7, the square had 3 4s, 2 8s followed by 1 9. When it has 3 6s and 1 7, the square had 4 4s, 3 8s and 1 9. Therefore, when the number has 6 6s and 1 7, the square will have 7 4s, 6 8s and 1 9. Thanks for watching this video. If you found it helpful, please subscribe to my YouTube channel and stay updated with more and more upcoming videos on various topics of mathematics. That will be extremely helpful to school-going students and aspirants preparing for various competitive examinations. With all the best wishes, thank you once again.